Hello students, welcome to this very first theory session of physical and chemical changes. In this session we'll be studying about the different types of changes which are occurring around us. Right, now these changes can be the change in shape or size or color or even the chemical nature of a substance. So we'll be studying about these changes in this session. Let's start our first session of physical and chemical changes. We see many things and changes around us. These things are made of different types of materials. Every day we come across many changes in our surroundings too. These changes may involve one or more substances. Now this is just a verbose part. See, you must be seeing lots of things like table, chair, computer, your window pane, fan, blackboard, chalk. So these are all many types of things around you, right? Or for that matter, us. Now these things are made of different types of materials. So your table is made of wood. The table in which you are sitting might be made of iron or some other metal. The blackboard, it's again made up of a different material. The chalk is made up of another material, that is calcium carbonate. Right? Now, we see the changes also. Changes like, have you noticed that when your teacher writes on the blackboard, the chalk gets crushed up and it comes out in the form of powder? See, when your teacher is writing, when she has completed the lecture, her hair might be having the chalk dust. Right? You might notice the chalk dust on her hair. You can crush the chalk. Or when you are, say, boiling water, the water changes into vapor state. Or in summer season, when you eat ice candy, that is also a state of water. Water is in solids form. So now matter can exist in either solid, liquid or gaseous state. And they can change from one state to the other. Right? There are many changes like see, souring of milk. That is also a change. If you tear paper, that is also a change. Right? So this session or this particular topic is about these changes. Now these changes are of two types. They are physical and chemical. Now let's start with it. See, setting curd from milk is a change. Again, the properties of milk have been changed. Curd is sour in nature, or sour to taste, and milk has a slight sweetish taste. So it's a change. Sometimes milk becomes sour. So souring of milk is again a change. If the milk is not boiled and kept for a long time, the taste of milk changes or it curdles up. That is also a change. Stretched rubber band. You can stretch a rubber band, right? Paper tore into pieces. You can tear paper into many pieces. That is also a change. Chalk crushed into powder. That is also change. Changing of water into steam also represents a change. So many more type of changes you might have seen. Right? Making a sugar solution from sugar in water is also a change. Making a salt solution is also a change. So these are all changes. Change means when there is a change in the properties of that substance, whether it's the physical property or the chemical property. Now let us first define what is a physical property. So, properties such as shape, size, color and state of a substance are called physical properties. Right? Now, a process in which substance undergoes change in its physical properties is known as physical change. In such a change, no new substance is formed. Say if you tear a piece of paper, is there any new substance formed? No, it's just that the size of paper has been changed. right? If you freeze water, or if you keep water in the deep freeze, what happens? Water sets to form ice. So what sort of change is it there is in the state of the substance? Does the property of water change? No. Right? If there is change in color, then also it's a physical change. So one of the characteristic property of physical change is that there is no new substance formed. It's just the change in shape, size or color. Say if you're dissolving indigo, or what is called as Neel in Hindi, in water, the color changes, the color of the water changes. It becomes blue. Right? That is also a physical change. Now let's see the chemical change. Chemical change, a change in which one or more new substances are formed, is known as a chemical change. A chemical change is due to some chemical reaction a substance is undergoing. You must have studied it in your previous classes that when a substance undergoes some sort of chemical reaction, it undergoes a change which is irreversible. Right? Say for example, the rusting of iron. You must have seen iron tools like spade, right, and or any other, say, exposed iron rod, shovels, which when kept outside they get a brown colored coating over them. Now that brown colored coating is called as rust. Right? Now that is a chemical change. What happens there? That the iron present on the surface gets oxidized, or the iron present on the surface of the shovel or spade or iron rod reacts with the oxygen and moisture of atmosphere and forms a new product, which has the property different from iron. Now that is called as a chemical change. Right? You must have seen your mother cooking food. Now, does the taste or the property of potato is same when it is cooked? A raw potato tastes different. It has got some different properties. But after cooking, it changes. It becomes soft. Right? So cooking is another example of a chemical change. Now say you're eating a puri or a bread or a chapati or anything. Now you chew it in your mouth. Now while chewing, what happens? The enzymes present in the mouth, they act on it, right, and break its components into small particles. That is it, they are digesting it. Digestion of carbohydrates starts in the mouth itself. Now that is also a chemical change. Right? So, when a new substance is formed, or when the property of the substance formed is different from the initial substance, then it's a chemical change. Property means it's not the physical property, it's the chemical property. Now when you're chewing a food, what is happening? The size of the food changes, right? The color changes. At the same time, the chemical components, the components present in the food, that is carbohydrate, protein, vitamins, they also change, right? So the protein, they are formed of long chains of amino acids. After digestion, these long chains break. Carbohydrates, they are complex molecules, but after digestion, they break into small glucose molecules. So that is an example of chemical change, right? Now a chemical change is due to what? Due to some sort of chemical reaction a substance is undergoing, right? Now let's see what is a chemical substance. Now what type of substance you'll call a chemical substance? Chemical substance it is a form of matter that has constant chemical composition and characteristic properties which cannot be separated by physical methods of separation like sieving, sedimentation, etc. are called as chemical substances. Say if I take an iron bar, right, that iron bar is composed of what? That particular iron bar is composed of small particles again. Now say this is your iron bar. Right? Now this iron bar has got some specific properties, right, which none of the other metal has. Now can I separate the particles of iron bar by sieving? No, it's just intact one solid particle. By sedimentation, what is sedimentation? Say if you dissolve salt or say sand in water and keep it for some time, these sand particles settle at the bottom. That is sedimentation. That is what? Settling of particles at the bottom. And this is the water particles. Now this is the sedimented one. We can't separate particles of iron by sedimentation. Or if I take a very simple example of water. Water is composed of hydrogen and oxygen. Can you separate hydrogen and oxygen by just sieving or sedimentation? No. Right? So what is a chemical substance? It is a form of matter that has constant chemical composition. Constant chemical composition means, say if you are taking water, this water can be from anywhere. It's a river water, or it can be water from a lake or a pond or a tap, or water from tap, right, in your houses. The composition will be uniform. That is, it is composed of 2 atoms of hydrogen and 1 atom of oxygen. Right? See, constant chemical composition and characteristic properties. See, none of the other liquids have got properties like water. So water has its own characteristic property, like iron bar. None of the other metals are having properties like iron bar. You can take gold, you can take silver, you can take tin, any other metal, chromium, nickel. So all are having their some sort of characteristic properties, right, now, which cannot be separated by physical methods of separation like sieving, sedimentation, etc. are called chemical substances. Now these chemical substances, when they undergo some sort of chemical reaction, right, then it is called as a chemical change. Say for example iron, there is a deposition of rust over it. See, this particular thing is deposition, the powdered form. How this powdered form is formed? By the reaction of iron with oxygen, right? So that is a chemical change or a chemical react. The chemical change takes place due to a chemical reaction. Or a chemical substance can be defined as matter of definite composition and properties. See, the composition is fixed and its properties are its own. None of the other matter will have the property of water. Say for example, water has its own property. Right? Now, see, a common example of chemical substance is pure water. It has its characteristic properties, similar composition, whether it's tap water or water of any river. That is, what is the formula of water, or what all water is composed of? Water is represented by the molecular formula H2O. Water has got 2 atoms of hydrogen and 1 atom of oxygen. So this is the composition of water, and you can take it from anywhere, right? I'll tell you what atoms are. See, salt water is not a chemical substance. It is a mixture of 2 substances, sodium chloride and water. Its composition is hence not fixed. It's not a pure chemical substance, right? Salt water is composed of 2 substances, sodium chloride and water. And the composition is not fixed. Say you can, this sodium chloride, its concentration or its amount in water can be very less or it can be very high, right? So its composition is not fixed, so it's not a pure chemical substance. Fine. Chemical substances are made of atoms and molecules. So there is a chemical substance, say chemical substance like your hydrochloric acid, you must have heard about. Sulfuric acid, you must have heard, right? Vinegar, which you are using at home, that is also a chemical substance. So now they are in turn made of atoms and molecules. Now, what do you mean by atoms? An atom is the smallest particle of a substance. Atoms may or may not exist independently. So the smallest particle of a chemical substance, say if I'm taking an iron bar, right? Or if I'm taking some gold jewelry or a simple gold plate. Now this particular gold plate will be made up of some things, will be having some constituents or will be having certain particles which are imparting it properties like say yellow in color, hard, right? Then it can be molded into any shape. So these are the characteristic properties of gold, right? So there are certain entities or the constituents which are imparting in these properties. Likewise silver. Silver is what? Shiny white or brilliant in color, and it has got a luster. It shines. Okay, it has got a different color. So silver, this has got a different color. Now silver has got its characteristic properties, gold has got its own characteristic properties. Now why are they so? Now these are in turn composed of small particles. Again, now these small particles are called as atoms, right? The small particles which a chemical or of which a chemical substance is made up of are called as what? Atoms. Like gold atom, silver atom. So millions of gold atom will combine and will give you one gold plate. Millions of silver atom will combine and they'll form some silver rod. Right? Now these atoms, say gold atom, it may exist independently or it may not. It may be binded with some impurity, right? Say for example hydrogen. Hydrogen cannot exist independently. An atom of hydrogen, it is represented by H. It cannot exist independently, so it is existing as H2. That is, 2 atoms of hydrogen combine and they form what? A molecule of hydrogen. Okay, so a hydrogen atom cannot exist independently. Gold atom can exist independently. Sodium atom can exist independently. But oxygen atom cannot exist independently. 2 atoms of oxygen combine and they form a oxygen molecule. right? So that's why it is saying an atom can exist independently or cannot, or they may or may not exist independently. Molecules are formed when two atoms join together and they can exist independently. See, two atoms of hydrogen have joined and they form a molecule of hydrogen. Two atoms of oxygen have joined and they form a molecule of oxygen. Right? Likewise, two atoms of nitrogen will join and they will form what? Nitrogen molecule. Like there is nitrogen gas in the air. You have studied about it. The gases in the air are oxygen, nitrogen, hydrogen, right? There is water vapor also. Now, oxygen, two atoms of oxygen, say this is one atom of oxygen, this is the another one. Now these two atoms of oxygen, they join and they form what? Oxygen molecule. Likewise, two atoms of nitrogen, they join and they form nitrogen molecule. Likewise, two atoms of hydrogen, they combine and they form what? Hydrogen molecule, H2. Right? So, now these molecules can exist independently. Now, oxygen in the air is represented by O2, nitrogen by N2 and hydrogen by H2. Okay? So, this is about the chemical substances that is made up of atoms and molecules. This is about the chemical substances. Now, these chemical substances can be divided into two major groups. This is a chemical substance. This can be divided into pure substances and mixtures. Pure substance means you can take any metal, that is sodium or iron, gold, silver, aluminium. These are all what? Pure. Right? A pure substance cannot be separated, or the particles or the constituents of a pure substance cannot be separated by physical methods of separation like sieving, like sedimentation, or by evaporation or any other process, by distillation. Right? And mixture. See, mixture, it's a mixture, say sodium chloride dissolved in water, salt water, or sugar solution is a mixture. Okay, and mixtures can be separated. You have studied processes like distillation. You have studied evaporation, condensation. So, you can separate a salt solution by evaporation. So, you just dissolve enough of salt in water and boil it. Water will be evaporated and what will be left behind is salt. Right? Now these pure substances can be further divided into elements and compounds. Elements means a single element. A single element, like I have given you the examples, like you must have heard about nickel, chromium, sodium, iron, right? Potassium. What all metals you have heard about? Gold. These are all what? Elements. And what about compounds? Compounds means these elements mix with each other and they form a compound. Like. So, in this session we have studied about the physical change and the chemical change. The examples of physical and chemical change, and also about the chemical substance. Right, now what is a chemical substance? What is it composed of? That is about the atoms and the molecules. In the next session, we will be studying about the classification of this chemical substance into the elements and compounds. The elements are further classified into metals and non-metals. Right? So we'll be studying about their classification and also about writing the symbols of the elements, about the symbols of the elements and also the chemical formulae. Okay, so thank you students, thank you very much for listening patiently, and do have a nice time ahead.